Hello guys, welcome to Lead Electrical Academy. Today we will see a problem on DC series motor. So DC series motor has an armature resistance 3 ohms and field resistance is 3 ohms and MEF constant is 0.15 and the motor speed is varied by a phase controlled bridge, and he has also given the firing angle value alpha equal to pi by 4. Pi by 4 means 45 degrees and the average speed of the motor is 1450 rpm. The applied AC voltage to the bridge is 330 sin omega t. 330 sin omega t means Vm sin omega t. So the V maximum value will be 330. Assuming the continuous motor current and torque, he has asked to calculate the current as well as torque. Motor current and torque we have to calculate it. First we will write the given data. Given that RA armature resistance is 3 ohms and field resistance is 3 ohms and MEF is 0.15 Henry and speed he has given as 1450 rpm and voltage is 330 sin omega t. 330 sin omega t. So V maximum value will be 330 volts, and he also given alpha value is pi by 4. Pi by 4 means 45 degrees, alpha equal to 45 degrees. So he asked to calculate the current as well as torque value. So from that, first we will calculate the armature voltage. So the armature voltage V maximum value will be 330 volts. From this, as you know, VA equal to, for a VA value, Vm plus 1 plus cos alpha by pi. So from this, V maximum value is 330 into 1 plus cos alpha. Alpha value he has given as 45 degrees. So cos 45 by pi. So the value will be VA, armature voltage value will be 179.31 volts. This is the armature voltage. Next we have to calculate the angular speed value. So angular speed omega equal to 2 pi n by 60. 2 pi n by 60. So 2 pi into speed value he has given as 1450 rpm by 60. So the value will be 151.84. This is the angular speed value. Angular speed is 151.84. so this is in radians per second, and we have to calculate the motor Rm equal to Ra plus Rf. Motor resistance is Ra plus Rf. Armature resistance he has given as 3 ohms and field resistance is 3 ohms. So the total motor resistance will be 6 ohms. So we can compare this with omega value equal to Vm by pi minus into 1 plus cos alpha minus Ia Rm by MEF into Ia plus M resultant. So while we neglecting this M resultant value, we can take this value. So as we calculated the omega value will be 151.84. No? So 151.84 equal to Vm by pi. Vm by pi means Vm value is 330 by pi into 1 plus cos 45 minus Ia value we have to calculate it, and Rm motor resistance will be 6 by MEF he has given as 0.15 into Ia, as MRS will be neglected. From this we can calculate this value 151.84 minus equal to 179.31 minus Ia into 6 by 0.15 into Ia. So I can calculate it, this 22.77 Ia equal to 179.31 minus 6 IA. So the IA value will be IA equal to 22.77 plus 6 equal to 179.31. So the armature current value will be 179.31 by 22.77 plus 6. So this value will be, armature current value will be 6.23 amperes. So we have calculated the armature current. Next he has asked you to calculate the torque. As you know, the motor torque for series motor will be motor torque equal to MEAF into IA square. So MEAF he has given as 0.15 into IA value we have calculated now 6.23 whole square. So the torque value will be 5.82 Newton meter. 5.82 Newton meter. This is the torque value. So we have calculated the torque value as 5.82 and armature current is 6.23 amperes for DC series motor. Okay, thank you guys. We will meet in next class.